Okay, I'm Zane Winyard. I'm going to be handling our little Q&A video here. I was our prototype and documentation lead. I wrote most of the reports. We'll be sending you several resources, including this little FAQ sheet I'm going to read off of. Sorry we can't be there today. We're currently at commencement walking for our graduation. Unfortunate timing, but we're going to do the best we can. So I have a few major decisions, like design decisions we made, I'm going to talk about, and then I'm going to go into some questions that we had during our design review and a few other people. So major decisions, the concept design choice, why we chose this general design, the tornado socket kind of deal. We had a few different things. We considered heat pipes, we considered water cooling, but this one got the highest score in our concept decision matrix, so that's why we pursued this design. Now, in terms of material choice, we printed this out of polycarbonate. We explored some other options, some carbon fiber filled 3D printing material, but while stronger, those all came in black, and we didn't want this to absorb a whole lot of heat. Polycarbonate is just about the strongest material you can print off of that isn't one of those composite materials, and it comes in white, so it worked out quite nicely. I have some numbers here. PLA, for reference, is one of the most common 3D printing materials. Has a bending strength of 75 MPa. Polycarbonate here has a bending strength of 108 MPa. And then a couple other carbon fiber filled filaments we were thinking of. PETCF being one of them, has a bending strength of 131. PA6CF is 151. So while those are stronger, they came in black and they're a little bit on the brittle side, so we went with polycarbonate. In terms of our battery, we picked these sort of hobbyist type batteries. These aren't the lightest or the smallest batteries out there, but the thing these have is they're readily available. They're lots of places, lots of hobbyist stores. You can buy them online quite easily. We could have picked a much lighter, like phone battery bank thing, but those go on and off the market all the time. So if we designed it around a specific model battery bank, who knows if that's going to be on the market still. We don't want the end user of this device to want to get another battery or a new battery and be lost. So that's why we went with these. We have this larger one that's 5,200 milliamp hours. We have a smaller battery in here, which you can just see it through the hole created by our impact testing. That's a 1,200 milliamp hour. So, on to some questions you might have. We unfortunately couldn't find an amputee, not through lack of effort, but we contacted the VA hospital, we contacted a couple of support groups, but we couldn't really get anywhere for whatever reason. Couldn't really do much about it. Conforming the device to the scan. So we received the scan from you guys. We were able to pull it into SolidWorks just fine and manipulate it around, but the way we were doing these, the cooling channels, the spirals, is basically projecting a line onto a surface. And if SolidWorks doesn't like that surface, then you're out of luck, and we're out of luck. We did have someone come up to us during our engineering celebration end of year thing. An engineering consultant here in town for the orthopedic industry that said he has some resources that could help us with that problem for whatever the next group does with this project if it's picked up again. But couldn't have those. On to testing parameters. So I know we ran through the testing a little bit quickly. We have an additional video for the judges to see during the testing section of the competition, since we weren't able to send any resources or be there in person. So you can see that full video for explanations of all the tests and the test parameters. We're also sending our test reports. So if you have questions beyond that, you should be able to look at those and figure them out. Customer demographics. Why did we choose an American male? Well, lots of data was available for American male people, and realistically, they're going to be the ones that will apply the most force on our device. They're way heavier, they can run faster a little bit. And so we made all of our testing for that, and so it will encompass all people, not them. I had a question about the flow rate of the fans. Each of these is about 6.8 CFM, so we have about 13.6 total CFM going through this. They're 5-volt fans. They have a little buck converter to convert the battery, which is 12 volts down to 5 volts, and that's how the fans are powered. Is the device waterproof? It'd certainly be water resistant at the very least. A little bit less so at the hole, but that's completely covered. We kind of ran out of time for exhaustive testing on this. This is kind of a secondary goal. We could easily make some, like a rubber gasket around the fan cover and the battery cover to improve that a lot. But we didn't get to it. Wouldn't the fans get blocked by your pant legs or your exercise shorts? It's possible if you're wearing really light material. If I turn the fan on here and pull the paper up to it, it does suck onto it a little bit, but it takes extremely little force to pull it away. So if you're wearing like a heavier material, slightly heavier material, that shouldn't be much of an issue. But we could probably redesign the fan cover to kind of have a little cowling to make sure that there's airflow. Okay. Would this be worn with a liner? Yes, this would. Preferably with, if you came across in our research a couple of liners with like perforations and air channels built in, that would be optimal. But yeah. And we had a question. We had a meeting with a prosthetist. He had a little bit of concern about the squishy PPE silicone liners filling in these air channels. Excuse me. But we're not entirely sure how much of a risk that is because we don't have any of those liners here on hand. We could make the passages a little deeper. We could put some wires in there to help prevent that. It's another design idea that could be iterated on in the future. So to sum up a lot of this, we learned a lot doing this project. We're really happy. We're mechanical engineers and we like to make things as perfect as can be, of course, but it isn't always possible. Excuse me. Through our impact testing, we learned that the front definitely needs to be a little bit stronger. That can be improved either from a design or a material perspective. This TPU that we used for our validation testing, pretty tough stuff. So maybe that would be a little better for the fan covers and the battery, who knows. Excuse me. Fan placement could probably be a little improved. As mentioned before, we could probably conform the scan a little bit using the tools that we found. But in a couple of iterations, we think this product could be marketable. It cooled the leg down significantly with our temperature testing, and I think with some tweaks it can be much improved. So thank you for your time. I hope you have a good day.